Greetings, everyone, and welcome to our online session slot number 4 of our Digital Week 2021. Today, I have with me here Professor Katerina Mitrokotsa from our brand new Institute for Computer Sciences at the University of St. Gallen, and she's going to speak about a very interesting theme and very actual theme. In fact, it's coming more and more, which is the secure, how IoT, the whole Internet of Things affects us, meaning how to handle our data going back and forth, and we want to make profit of it, and the companies wanting also to profit from that, how to handle this. Katerina, please, I welcome you. You may come for us all here. One last thing, people, don't forget, you can ask your questions on the Q&A button, and we will handle them once Professor Katerina is over with our presentation. Then we move to the questions and answers. So have fun, and now I disappear.
Okay, thank you very much, Julio, for the very nice introduction and for inviting me in this webinar to talk about very exciting things. Secure and private computing. I'm sure many of you have heard about the importance of security and privacy and how also this can be combined with the Internet of Things. So what is exactly the Internet of Things, first of all? This is a nice picture. It's from a city in Sweden, Gothenburg, where I used to live a few months ago before moving in Switzerland. So you can see here various applications. So we have gas monitoring, waste management, smoke alarms, water meters, flow control, and all these are applications that are working, that they are used in our everyday life based on the Internet of Things. So you may be familiar with the small devices that and the gadgets that we like to wear and have, like wearables, or drones, or you have heard of self-driving cars. So a good question would be for you now, just to see how active and participating, how much you're participating, is how many IoT devices do you really have? Can you give me some indication? You can use the chat. Okay, so I see, yes. So how many IoT devices do you have? This is a nice question. Smart industries. Okay, so you are involved on a smart industry. You can write on the chat. Okay, and maybe more ideas will come in while I present. So indeed, the Internet of Things is not only the small devices, the gadgets, the smartphones, the smart watches, or the self-driving cars that we have, but it's also involved on the smart industry, the smart buildings, on home automation. So you might have heard or that we can save energy for measuring our consumption, electricity consumption, even for road safety, for paying in an automatic way, in a fast and automatic way using NFC communication, or even in the supply chain management, and even more importantly, in the healthcare applications, so how we can monitor patients remotely while saving some time and cost, I would say. So the Internet of Things has many advantages. The Internet of Things have many advantages, but they have also many security and privacy risks. So let me give you some examples to get a bit more to get the idea of the security and privacy risks that are associated. So in healthcare, there are many people that need to monitor some levels of, for instance, the insulin level, some measurements in their body. And these measurements are then subsequently could be transmitted to a cloud server, and then some information from a healthcare provider could be provided to the patient. However, it has been shown by researchers that many of the information that is being transmitted from patients to cloud servers via healthcare applications, they are not really secure. So this transfer of information is not performed via secure connections such as HTTPS. And on a study that was performed some time ago, it was about 80% of the health applications that were evaluated, and most of the applications did not meet the legal requirements regarding privacy. Okay, so another nice example would be to think about the Strava fitness application. So people that are rather active in this and they want to go running, etc. There is this nice fitness application that gives you some options to monitor your progress. So this was done also by some soldiers, US soldiers in a military base in Afghanistan. And while they were going around to get some activity and run, a lot of information was collected from the Strava application, and it was possible to reveal a very confidential information, the location of the US military base in Afghanistan. So quite crucial information can be revealed through these smart applications and the IoT. Let's see another example. So cars, I'm sure you probably have a car, and these cars are using some wireless connection to lock and unlock. They call it keyless entry, but actually cars are not only using these simple methods to access control a car, but also they can be considered like computers or even networks on wheels, as we say. So they often transfer information between cars, but also from car to infrastructure to measure the speed of a car or to see how far ahead the traffic is. So that everything is interconnected and a lot of information is being transmitted. And this connection and this information can lead also to some serious security and privacy risks. So for instance, a car, a Tesla car, was being demonstrated that it can be taken, the control can be taken remotely from 12 miles away. So this makes us really worry about our safety in some cases. So the Internet of Things, they're not only these small devices that are collecting information for us, but on their own, they cannot do that much. So they are very useful indeed, but often they need to connect in more powerful computers like cloud servers. And there, in order to store a lot of data, and the cloud servers having more computational power can use the data in order to compute things that will be necessary for other parties, for service providers. So for medical centers, for a health insurance company, for multiple companies. So the IoT, we can say it has multiple aspects, but these positive aspects that it gives us the advantages of the applications that they provide us, they also come with the privacy and security issues. So what can we do really to guarantee some security, to provide some good reliability and security and privacy guarantees with the IoT. A very first step would be to have some privacy regulations that will make things more regulated. So a very well-known data privacy regulation. I'm sure you have heard of this, the EU General Data Protection Regulation, or GDPR, that came into force in May 2018, is one of the most important regulations that help us to enforce how our data will be used in a very more conscious way and protect users and clients in general. So what we want to avoid is to have a data breach. So we want to avoid waking up a morning and hearing on the news extra bad news and your data have been stolen. So we want to make sure that we provide a good environment where we have good applications with high quality, but also good security and privacy guarantees. So this gives us a very good motivation to do research on. So I've been working with my team on this very important problem, and I'm going to give you some highlights of our research in this area. So now that you get the general picture of what is IoT and what are the security and privacy risks, let's try to narrow down a bit the problem. So let's assume that we have Alice, and Alice is a client of a health insurance company. So Alice wears a smartwatch, and using this smartwatch, she can measure her activity levels. And the health insurance company says that, Alice, if you're active enough, and I can see this from the data collected from your smartwatch, then I can provide you a discount on your health insurance package. And this indeed is a realistic setting that is adopted, I believe, from a health insurance called Generali in Germany, probably also in Switzerland, where discounts are provided to active clients. Now, a cloud server may collect all this data. So the data from Alice go to the cloud server, and then the server may compute, for instance, the average activity levels of Alice, and then send this information to a health insurance company. The company wants to guarantee that everything is fine, everything is correct with the computation. So if we try to see what are the main concerns we have here, is that Alice, first of all, wants to guarantee that the information that is being collected from her would remain confidential. So no sensitive information about her activity levels should leak. So how often she runs, or where does she go usually to run, or how many kilometers, etc. The cloud server we consider is untrusted. So the data that are being collected by the cloud server should remain private. And then the health insurance company wants to verify that what the cloud is computing on Alice's data is actually a correct computation. So if X is the data and f of X is the computation on the data, we want some guarantees that indeed this computation is correct. Another issue that the insurance company may have is that they want to verify that the data indeed come from Alice and not from a friend of Alice or a relative of Alice that is very active, but Alice herself is more relaxed staying at home on her couch. Okay, so we have all these concerns, and then we have introduced also another party here, an auditor. An auditor is someone who would actually check if the health insurance company is indeed providing the discount to Alice as it promises to do. So it is actually providing a check on fairness and transparency, that everything works out correctly. So we want to verify that the company is fair. So this is a complicated setting. If we try to summarize what is happening, we have the data owner, Alice, that generates data through her smartwatch, for instance. She may authenticate, she may even encode this data through the smartwatch. And then we have a cloud server that is very powerful, can collect a lot of data and can compute, can perform very important, very time-consuming and resource-consuming computations. So having access on the data can compute on this data, f of x, for instance. And then we have the health insurance company that wants to check that the data indeed come from the client, that the data are correct. And of course, the auditor that wants to guarantee that everything is fair and transparent. So the data owner in this case would like privacy. The cloud server should not see the data. And the health insurance company wants integrity, that the computations are correct and the data indeed come from the original client. And finally, the auditor wants transparency and fairness, so wants to check that everything is working as it should be. Okay, so this is actually a very complicated problem if you think about it, because we have four different parties and each party has its own restrictions, its own agenda on what they want. So let's see how we can solve this. Now, considering the fact that we have data and then we have a cloud server that computes on the data, and we want a guarantee, a control that the computation is correct, what we need is what we call public verification. So we want not only the company to check that the computation is correct, but we want also the auditor or even many other verifiers, other entities to check that what is being computed is indeed correct. And this we can call a public verification. So if we have public verification, anyone can check that what is being computed is correct. So how can, oops, okay. So a good question, and I would like to see you participating maybe here, is how can we solve this? So please write any ideas you may have on the chat. I'll give you 1 minute maybe to think about how can we solve the problem, this complicated problem. So we want privacy. How do we solve usually the problem of privacy? What comes in the mind immediately as a simple solution? It's a tricky problem, so maybe anonymization. Yes, that's an interesting. Okay, some suggestions is to anonymize the data. That's an interesting possibility. So okay, with blockchains, okay, we're going into very different methods here. Privacy, encryption, and pseudonymization, and distributed ledgers, I see. Okay, so very nice. I'm very happy that you come up with some ideas and participate. So indeed, anonymization is something that I would not recommend because it has been shown that in many cases data that have been sanitized, as we call it, so we remove the identifiers, for instance, of the data, it is still possible to de-anonymize the data by checking double databases. So by cross-checking databases, it's possible to identify people, and there are many examples that have shown this. So encryption is a basic thing that we can do in order to achieve confidentiality indeed. So if we encrypt our data, we do have a good level of privacy, confidentiality on our data, and how to solve having integrity, which means how to guarantee that the data indeed come from the data owner, from Alice. This is usually done using digital signatures, if you have heard of the notion. So by digitally signing some data, we can guarantee that the data indeed come from a single person, because only this person should have the secret key used in the digital signatures. Yes, so I see also some very, very nice suggestions on defining what exactly is the sensitive data and make sure that we are covered for regarding GDPR. So I'm very happy that you are actively thinking about this problem. So a naive solution would be, as I said, to encrypt the data, because then we would have privacy. We will have confidentiality on the data, and sign the data, because then we would have authenticity that the data indeed come from Alice, from the data owner. This, however, creates the constraint that then we have to compute on encrypted data. Okay, so then we have the cost of encryption and the cost of the signatures, plus the cost of computing on encoded data. So doing separately, it's rather costly, and we were interested to see if it's possible to solve this problem by combining the encryption and the signing on the data, which is called sign encryption. So so I will give you more details about this, but let's see also what has been done in this area. So for instance, this is a huge area on being able to compute, to outsource computations to untrusted cloud servers, and then check that the computation is correct. So in this area, many people are checking different properties. So first of all, we want security and privacy, because the cloud server is not trusted. So we want to make sure that the data will remain, the sensitive data will remain private. And then another property that we're interested in is generality. How general is the function that we want to compute? So this very simple is to compute just an addition, compute a multiplication on the data, or compute an average. So find out what is the average activity level of a user. And another property is public verification. So how can I check? Give the possibility not only to one party, but to anyone to check that what is being computed is correct, without revealing information. So most of these works actually checked some of these properties, but we wanted to see if it's possible to maintain all these properties at the same time. And we found a solution that satisfies all properties indeed. So we proposed homomorphic sign encryption. It's a cryptographic primitive for solving this problem. So sign encryption is a primitive that allows you to encode data and sign them at the same time. So we solve with this the privacy problem, and we guarantee also the authenticity of the data, that indeed the data come from this specific user. However, the existing sign encryption primitive does not allow to compute on sign encrypted data, so it's not possible having this encoded data to compute on them, and it was not possible to check in a public way that the computation is correct. So these two were not satisfied. So what we did was to capture these extra properties to be able to perform computations on encoded data, and more precisely on psi-encrypted data. And it sounds a bit like magic, but what we actually do is that we have data that are being encoded using some secret key, and we're able to perform computations on this encoded data, never seeing the raw data, the non-encoded data, and finding out a result by just using the encoded data. So compute by using the encoded data. It may sound like magic, it's not magic, it's actually based on some mathematical operations and some mathematical tools. So this was very interesting, and we thought, okay, this indeed solves an important problem, and we were very happy with this. However, we thought, okay, having data coming from a single source, it appears in many applications indeed, but in many cases, the data come from different sources. So we have data from different databases. An example, so then we want to do joint computations. An example is that, for instance, we have information for patients from 3 different medical centers, medical center A, medical center B, medical center C, and we want to take the data from these different databases and compute on them. A very simple example, I want to see what is the number of patients suffering from this disease from these different databases. So I want to combine information from different sources. And in this case, I want to compute, for instance, the sum x1 plus x2 plus x3, but I want also a proof. I want something that will help me to check that indeed what I'm computing is correct. Another example would be that maybe I have a smart grid measurement. So I have different households, and I'm collecting with some sensors the electricity consumption, and the company that provides the electricity wants to measure what is the electricity consumption in a specific area. So they collect the measurements, and they want to do the joint computation, but they also want a proof that what is being computed is correct. So what we propose to solve this problem is what we call multi-key homomorphic signatures. So it sounds a bit complicated, but what we do is we allow to each of these entities to sign their data and send data and signatures to a cloud server, and then the cloud server can compute on the data and then provide also a proof that the computation is correct. In this specific case, in this specific problem, where we have computations coming from different sources, we were able to check the boxes of security, integrity, public verification, so anyone can check that what is being computed is correct. And it's something that works for any type of function, but the privacy box is not covered. So the data are sent and the cloud server can see the data. So we were intrigued by this, and we said, okay, how about we cover also the privacy issue here? So let's see. So you see, research is always very fascinating because you have always new questions coming up and you try to solve them. And we continued in this direction. Another concern we had was that indeed, it is very realistic to consider that you have data coming from different sources, so for instance, from different users, but most of the existing solutions rely on a single cloud server. So all the data are centralized and sent or the communication is centralized and the computations are performed by a single cloud server. So we don't like, we have an issue with trust here, and we don't like having a single server taking care of this because it's a single point of failure. So we said, what about having multiple servers that do the computation? So in this case, we're interested on distributing shares of the inputs of the data that the clients have. So if we don't encrypt the data, but we split them into small shares, into small pieces, which is actually another way to guarantee privacy. So we split the data into pieces, and each server takes a piece of the data, and then the servers are computing, are performing partial computations on the data and provide the final result. So it could be x1 plus x2 plus xn equal to the final result that we want, y, as well as a proof that indeed the computation is correct. So we proposed actually a primitive, a cryptographic primitive called verifiable homomorphic secret sharing that provides security and integrity guarantees, allow us, it allows us to check that what is being computed is correct, and the privacy, because the data are not sent directly to the servers. And it works for the basic operations of addition and multiplication. So just to give you a hint of how this is working, we may have here different households, and each of these households may have a secret input, for instance, the electricity consumption. And we may have here the servers that are performing the computation. So the data are distributed, only shares of the data are sent to the servers, and having this information, the shares of the data, the servers can compute some partial values, y1, y2, y3, y4. Using these partial values, it is possible to compute the final result y. So this is a multiplicative secret sharing, as we call it. Although this has been proposed before, it doesn't provide the guarantee for checking that the computation is correct. So how can I verify that what is being computed is correct? So we have relied on this notion of verifiable homomorphic secret sharing, where each server indeed computes a partial evaluation of the function. So a partial computation is performed by each server, and then by combining all these partial computations, you get the final result of the computation. But we have also added a proof that allows us to check that indeed what is being computed is correct. So we were very happy with this because this is rather efficient and not as heavy as other solutions, and we're continuing in this direction in order to see how we can solve more complicated computations, not only addition and multiplication, and we're still working on this area, but we're very, very happy with the existing results. Another interesting direction that we would like to explore is to see how this can be translated to the quantum setting. So I'm sure many of you have heard of the quantum computer and the quantum cloud that is coming, and the very powerful quantum computers. So indeed, there have been some important results from from physicists and quantum physicists on constructing these quantum computers. But a question would be, if we ever have this quantum computer that can compute all these things, these very expensive computational things for us, how can we check, how can we verify that what is being computed is correct? So a classical computer, like my laptop here, works with simple bits, like zeros and ones. Everything is translated to a 0 and 1. And a quantum computer works with qubits. So it's very different to what is happening with classical computers. So it will be interesting to check that what is being computed with quantum computers are actually correct. So how can we translate this area of verifiable computation to a quantum setting? So this is something we're still exploring. So I think I'm going to summarize now about my presentation. I will welcome a lot and questions you may have in a discussion. So to summarize, the Internet of Things and the IoT devices have very important advantages, and however, they're associated with some serious security and privacy risks. So sometimes people say, let's try to deploy, to develop this now, this application, and we'll think about security and privacy later. However, this does not work. You cannot deploy something and then add on the security and privacy. We need to have solutions that incorporate security and privacy in their original design. So we need to rethink a lot of things. We need to rethink about the architecture of the data, of our system, who has the data, who controls the data. We need to have open solutions that allow transparency and open audit. Having support from legislation and providing economic incentives, a representative example is GDPR here, helps a lot. It is essential to protect human rights. Privacy is a very important human right, so we need really to do our very best to protect this. Further advances in homomorphic computations are for sure needed, but we already have some important results that can be used in practice. So people should be able to adopt this in real life. And of course, having decentralized architectures, so avoiding having a single server that performs all the computations, that can be a single point of failure, but having a more decentralized architecture can definitely be a very good solution to guarantee security and privacy. So, well, that summarizes my talk, and thank you very much for your attention. And I'll be happy to answer questions if you may have.
So great, we see three questions here already, Katerina. First one being, what do you define as sensitive data?
Yes, what is sensitive data? Can be things like even the electricity consumption that you have at home can be indeed sensitive information. So, for instance, it has been shown from researchers that by monitoring your electricity consumption, someone could find out your routine. So when you're at home, when you sleep, when you have dinner. So I would say this is private information, but sensitive data is even all this information that are associated with medical things. So what diseases someone may suffer from, or sensitive data can be anything really. It can be what you're voting, many different things, right? But even things that you may not think are sensitive, so for instance, your electricity consumption, it can lead to infer information that are private and sensitive.
Thank you very much. There is another question here. Who owns and controls the servers and the computations done on the cloud servers in your model? If it's the health insurance running the cloud server, we again have lost privacy, for example.
Yes, indeed. So often these companies, they don't have the capacity of storing a lot of data, and they often need to rely to external cloud servers. So external cloud servers could be Google, Amazon, any of these very big providers that have a lot of storage in many different countries. So in many cases, the companies need to outsource the storage and the computations to third parties. And then often we don't know where these data are stored. If the cloud provider, the one that says, yes, I can store the data and yes, I can compute for your company, whatever you want to compute, we don't know if the data are indeed stored or they are deleted and then they give us imaginary results. So there's a big uncertainty on how these data are handled. And in our security model, we take the worst case scenario. We consider that the cloud servers are not owned by a specific company, they're by a completely untrusted source, and thus we want to check that indeed the data remain secure, remain private, and the computations are indeed correct.
Okay, there's a critic exactly about that point. One of our participants says that, look, give me that problem one. Most apps are for free, exactly to collect our data and sell them somewhere. And the problem two, that even servers, probably clouds, may interact and reconstruct parts of this data sent from other different servers. How to handle that?
Yes, so if the data themselves are encrypted and the key is not given to the cloud servers, they cannot do much, right? So the problem is that usually if the data are encrypted, then the computations can be very expensive. So there are solutions, but in some cases, the solutions are too heavy to be adopted. Now, I see another question that if the data is splitted between the different measures, isn't okay. So when I say splitting the data, this is, I would say, a mathematical definition of splitting the data. So this does not mean that I will separate the data into pieces, realistic pieces. It is like for instance, if I have, if my activity level is today 10,000 steps, there is a special mechanism that's called secret sharing mechanism that allows you to give to different parties different values, and by using some of these values you can reconstruct the 10,000. So it is not exactly splitting literally, but it's following an algorithm in order to split, to give some numbers that if you can if many of these parties, many of these servers together collaborate, they can reconstruct them. But there is a security model that gives a number on how many servers are allowed to collaborate in order to do that. So we think for different worst case scenarios here.
This is very interesting and ties well to another question here, which is like, blockchain technology also works using a similar concept of like having multiple servers with a lot of information that can only combine it, be reconstructed. So would blockchain technology not cover all these concerns? And what's your opinion?
Yes, okay. So this is a very good question because blockchains is a big is very much in trend now, and people think that by using blockchains you solve everything, which is not really the case. One of the main characteristics of blockchains is that it gives you this decentralization, which is a very good thing, and it also provides you transparency. So that's the main idea, that you can see everything, you can see all the data, and not a single source is responsible for storing the data. However, the privacy issue is not solved very well at the moment with blockchain technology. So often, when you're incorporating a blockchain model in your system, a lot of privacy is lost.
Okay, this is interesting because it ties well to the next question, which goes in the exactly opposite direction. Instead of decentralization, why not centralize? The participant here in the camp wrote, to avoid data traffic and to avoid latency in critical applications, should we not think about edge computing and how to solve the problem, respectively, how can we have security, etc., on the single IoT device? Like the device itself would handle the Löwenanteil, as they say in German, the bigger part of the problem, and then send it encrypted or whatsoever further on. What do you think?
Yes, indeed. Storing things centrally makes things easier from the computation perspective, but it jeopardizes somehow the possibility that something will be down, the server will be down, and everything will be lost somehow, or that it may take some time until another server will take over and continue the computations. The other direction that you refer to, where devices themselves are becoming more and more powerful. So, for instance, a smartphone can do already a lot of things on its own, and thus many of the computations can be performed partially on the devices, and then move on some extra computations to more powerful servers. So this is something that is being adopted, and we're looking into it. So, for instance, if I'm not certain if you have heard of something called federated learning, where a machine learning model, usually a machine learning model, how do we train a model with machine learning? We collect the data, for instance, from many users, and all this data go to a cloud server, and the cloud server uses the data to train a machine learning model. So because of these privacy concerns, what is happening now is that often the devices want to do some partial computations, so the mobile phone can do some computation locally, and then keep the data on the phone, do some computations, so some parameters that would be used on the machine learning model, and send only the parameter, not the data raw to the server. And using these parameters, the server could then train the model while the data remain on the mobile phones. Okay, so this is very connected to our work, because we have, even if this happens, it has been shown that the parameters, not the data, can still leak information, private information, for very sophisticated attackers. And even if this happens, the cloud server, the central cloud server, needs to, for instance, use these parameters in a specific way in order to train the model. So there is some computation still on the cloud server in order to check that everything will proceed well. So having this verifiability is relevant even in this case.
Okay, so we have a final comment here before we close the session. Thank you very much for everything that you know, Katerina.
Yes.
Going exactly in this direction of, okay, there's a lot of danger out there. So one of the participants said, at the end of the day, every citizen needs to learn to save his or her data in an encrypted way and needs to be able to be in the driver's seat when it comes to deciding with whom you share your data.
Yes, absolutely. We need to increase our awareness, I would say, for how our data, because often we use our mobile phones and we just say accept, accept, agree, agree, and we don't really know what is happening there. So I believe that the users themselves need to understand that by pressing this accept, accept, agree, agree, many things can happen on the background, first of all, but all the users on their own, they cannot do much. So the support from legislation and these economic incentives for companies are necessary in order to give more power to the users.
Thank you very much, Katarina. So now I'm going to move us to the final parts of our presentation, like me closing the session and making a short teaser of what is to come. But before, I want to thank you very much for giving this very good insights, like people are writing here to the same. Pretty interesting session as well.
Thank you so much.
Thank you very much, Katarina. And
thank you.
Our Digital Week quest continues, because tomorrow we have exactly this machine learning topic being brought to the front, this time in the form of assessing projects. As we know, machine learning is a sort of a technological voodoo to see the future, to detect parameters, to know how people do stuff, to learn more and more, like the machine learning about us and our habits. So could not the machines help us know if a project is going to be successful or not? So that's the topic for tomorrow. And in the afternoon, we have, in the afternoon, we don't have anything because the teacher is sick and had to cancel. It would be a session about creativity being used with AI, which would have been awesome. I'm going to bring that later on in the year when he's back well. And therefore, we have the other two sessions that come, I have to go more here, that come on Thursday. In the morning, you have AI and technology being used for recruiting, to making finding the right people easier and keeping the people as well. And in the afternoon, we see this being used already in action during practice, like I have a team, how do I assess my team? How does our team use technology to improve ourselves? And the final two sessions will be on smart mobility, the smart mobility revolution. We started with this topic on Monday, and we continue. We finish it on Friday as well, talking more about what's coming up in the digital sector here. And in the afternoon, in fact, with the teacher that also does the mobility part, is one of these, doing the technology in the medical sector, the health sector. So with that said, I thank you all very much, and I finish the session here. See you tomorrow, probably.